Well, the first problem is the stochastic process xt is a real Weiss stationary with also autocorrelation Rxx tau and power spectral density Sxx omega show that Rxx tau is a real and even, and Xxx omega is even a negative. So first we can know that X is a real Weiss stationary. Rxx tau equals to E xt plus tau xt. So also Rxx tau is real. And also this equal to Rxx t plus tau t. And so E xt plus tau xt equals to E xt plus tau. And this equals to xt Rxx t plus tau, and this equal to Rxx minus tau. So Rxx tau equals to Rxx minus tau. So we can get Rxx is an even function. The second problem is that Sxx omega is even and non-negative. Sx omega equals to from minus infinity to infinity the integration Rxx tau e minus omega tau d tau, and this equal to Rxx tau cosine omega tau d tau minus j Rxx tau sine omega tau d tau. From that we can know Rxx tau is an even function, cosine omega tau is an even function, and sine omega tau is an odd function. Because odd function times even function is a odd function, and minus infinity to infinity is symmetric. So the behind one is equals to 0, and the even function times the even function is a even function. So Sxx omega equals to from 0 to infinity 2 times integer from 0 to infinity Rxx tau cosine omega tau d tau, and this equal to 2 times from 0 to infinity Rxx tau cosine minus omega tau d tau, and this equal to Sxx minus omega. So Sx omega equals to Sx minus omega, so Sx omega is even. And also we assume h omega equals to 1 when omega larger than omega 1 less than omega 2, and 0 elsewhere. And we can get that EYT square, which is the power, equals to 1 over 2 pi from minus infinity to infinity h omega square Sxx omega d omega, which equals to 1 over 2 pi omega from omega 1 to omega 2 xx omega d omega. And because the power the energy is always larger or equal to 0 and omega 2 larger than omega 1, so Sxx omega is always larger or equal to 0. So we can get Sxx omega is a negative function. So we can say that Sxx omega is even and non-negative. So this is the solution for the first problem.